Okay. So the outline of today's presentation is that we'll start with a little update on our development progress and our timeline of our plans. Then we'll show a little general introduction to the user tools that we're showing today and take some questions on those. Then we'll look at the SESHA case study. Specifically, we'll do a demonstration of how the tools can help in both harvesting data and in building schemas. The second one there is specifically targeting the SESHA archaeologists. Then we'll look at our line case study, and by that we mean our line partners, our technical partners, particularly in Leipzig, Oxford, and in Wolters-Kluwer, Germany, who we're just introducing them the use of our graph and ontology analysis tools. And again, in all of those things, we'll give a brief demonstration, and then we'll take questions, and hopefully we'll be able to, the software will be able to help us answer the questions, we'll be able to show you what we mean. So first of all, I just wanted to give you a brief development timeline to put all of this into context. So Dacura's development, it goes back quite a long way. I started in 2009 with some designs and experiments for a system like Dacura. I was involved in a citizen journalism publishing outfit, which I eventually came to the conclusion needed much better quality controls and much better control of the structure of data. So between 2009 and about 2011, I experimented with designs and so on. 2012 and 2013, I started to build prototypes. 2014 was a bit of a write-off because I spent most of that seeking money from the European Commission. But eventually that came good. In the 1st of February 2015, the Align project came on stream, and that was particularly important in development because Gavin Mendel-Gleeson came on board between 2015 and the May the 22nd of this year, when we completed the first version of the platform. Both of us have been working hand in hand on all of that code development. Things again have accelerated since then. The development of the user tools began at the 1st of June 2016. It's only 2 months ago today, and as anybody knows, that's a very short time in computer programming. But one of the reasons that we put so much effort into a platform development with a proper API and an engine is because on the hypothesis that this would make development much easier and faster, and we would be able to scale it much quicker by getting a web developed and so on, rather than the people who had to grapple with the mathematical logic and very large triple stores. And so we have contributions from 3 new members in this code we're going to show today.
My name is Oran, and I've been working on the frames.
My name is Amanda, and I've been working on maps.
And I'm working on the notations.
The idea of Dacura is pretty simple. We help groups of people to collect high-quality data sets, no matter what type of data they want to collect. We want to give the power of data to the people. Dacura's user tools come as a browser plugin. Once it is activated, it allows the user to access all of their data collections and all of Dacura's powerful tools from within their browser, without interrupting the flow of their work. In the next section of this presentation, Gavin is going to show us the tools in action, using the SESHA use case as an example. Thanks for your attention.
So as you can see here, the Dacura console allows you to browse through content on the web, and we can choose from a number of different collections that store different types of information. We can then choose a particular class with which we want to associate this information. Now, if we turn on our roles as a data harvester, we can then go and add a new element, a new polity in this case. We're going to add this, and the ID we will call Latium test, and we can add a label to it and some comment that goes along with this data point. After this, we can add any number of properties, and there are a large number of properties that are associated with a polity. Each property can be associated with some class, or some superclass, or some subclass. Here we're adding irrigation systems, and if you look through, you see that there is no irrigation system variable present. in the current Seshat codebook or wiki. We can also add other properties. There's a lot of properties. We have alternative names. This is listed in the wiki as Lazio. We can add a UTM zone, which is also present there. And we can add a polity territory. And here you see a map comes up for us. And we can zoom in, and using the map on the wiki page here as a template, but it could be any web page, we can go ahead and define the polity territory. Carefully. Okay, and this is actually going to define a polity, or a polygon for this polity. And this polygon will be stored in the triple store and can be searched. And from that, we can derive other information like the territory in square kilometers, or whether it has overlap, or it can be used for geographical search. Now we can go back and we can see that this is now in the database, and we can ask for the various properties of this data point in the database for Latium tests, and we see that it has irrigation systems unknown, 33T as the UTM zone, and Lazio as alternative names. And we can see here that it has stored the polygon for the polity that defines its territory.
Your attention.
This section showcases the ontology management service. Here we are adding a new ontology. This is the vocabulary of interlinked datasets, or void vocabulary. You can see we enter a prefix, title, a namespace, and the contents of the idea of the ontology and its type. We can then test the ontology, which shows a number of errors. These errors describe various kinds of errors created or identified by the Dacura Quality Service. We can then add the ontology to the Dacura Ontology Management Service. It will then be displayed in the Ontology Manager. Now we can see the ontology after it has been added to the Ontology Management Service. We can view the ontology in a variety of different formats, such as internal JSON storage, JSON LD, Turtle Terse RDF, and many others. We can view ontology metadata, such as the title and namespace, in the Metadata tab. We can view the history of updates which have been made to this ontology. We can see the details of each of these changes by clicking on them. We can view a history of applied updates to the ontology in the Updates tab. The Analysis tab allows us to perform quality analysis on the ontology. Here we can see warnings and errors which have been detected in the ontology. We can view summary information by hovering over these boxes. In addition, we can click on them to see these in greater detail. This tab shows a variety of errors which the Data Quality Service has detected. This tab shows the tests which are currently being run on the ontology. This tab shows the ontologies which are imported into the void ontology in order to support it. The Dependencies section shows the external links and dependencies which the ontology depends on. Structural links shows the class and property relationships included in the ontology. The dependencies shows the ontologies which are referenced in the ontology. Schema links shows ontologies which contain properties that are used in the ontology. The Vocabulary Utilization tab shows how the ontology is used. It provides a breakdown of the subjects, predicates, and values of the various namespaces within the ontology. In addition, it shows the varying types of predicates which are imported by the ontology.